Okay, we had left off with approximately right here, I believe, and one of your, I do remember one of your vocab terms was definition of what mechanical energy is, and there it is right there. When we see both stored and okay, what we see happening is with both stored and the movement energy all together, and one's mechanical energy. Okay, so with that, we've gone over some of the story problems that are associated with this. We'll wrap part of this up today. Is anyone have any problems with these story problems that you know of? They're still in the box right where I left them last Friday. When you're doing those questions, was there anything about that that I just don't get? And we're probably getting better at these problem-solving activities. Maybe yes, maybe no. Okay. All right. So you'd have to think of this here. We're talking about roller coasters, okay? And I suppose swing sets, but you almost have to have these in slow motion because the human eye just can't see this without slowing time down. Why especially this, a swing set? Why would that be an example of what we consider mechanical energy? Well, we need to see or know what mechanical energy is to begin with, and that is both kinetic and potential together at the same time. And what that means is, going back to this question, how is this an example of both kinetic and potential energy on a swing set? And again, we need to slow time down. Picture what's happening on a swing set. It's kind of similar to a pendulum. If you know what a pendulum is, like on a grandfather clock, what's a pendulum? It swings back and forth like this. I guess we could use that as an example as well, just like your swing set. Okay? So if you are sitting on the swing set and you say higher and higher, the higher that you get on that swing, what's going to happen? The faster you're going to do what? Faster you're going to go. Okay? So if we could slow time down, and if you're looking at a picture of this, the higher that you get when this is at its greatest, potential energy, you have to know what that means. What is potential energy to begin with? Is it movement or is it stored energy? It's stored. So when this is at its highest, okay, so what's the formula for potential energy? Mass times gravity times height. Height or distance is usually associated with height. So when this is at its greatest, when it's highest in the air, okay, that's going to be a high number. But what about kinetic energy? Is that going to be pretty high or pretty low? Think about when, again, like on that grandfather clock as well, when that gets up to its highest peak right here, it eventually approaches what value? Zero. Exactly. So if it's approaching zero, what's the amount doing? Getting greater or less? It's getting less because it's approaching zero. Then, after it's at its greatest potential energy, it begins to swing back down, either the swing or the pendulum, and once it gets back down to the bottom, this is at its greatest what? Potential or kinetic? Greatest kinetic energy, because when it starts swinging back this way, it's going to start to do what? Approach what value? Zero. Right. So as we look at that, that's the difference between this kinetic and potential energy. But when you put both of them together, we get mechanical energy. All right. So as we move forward, okay. was also one of your, and it may have been tricky, but I do believe one of the things that was mentioned, I think it was like question number 1 and question number 10. It said, now be careful with these, because it started out saying, due to, or something along the lines of, because of human nature, you may forget to do this when solving for velocity in the kinetic energy formula. Okay? Now that's different than, it may be due to human nature, you may forget to do this while solving for kinetic energy. Those definitions were very, very similar, but if you're given the kinetic energy and you're solving for velocity, what must you do? You have the kinetic energy, so you're working backwards and solving for velocity. You need to do what? Take the square root of that. But if you have all the variables and then you're solving for kinetic energy, then you have to square it. Okay? So a little bit of context with that. Okay? And this is referring to just what we were talking about on that swing set, or in a grandfather clock, like that pendulum just going back and forth and back and forth. You're going to start putting you into a trance pretty soon, aren't we? Just going back and forth, back and forth, until we start going crazy like this, right? How come I don't see any heads bobbing up and down like this? No. You people can smile. It's okay to smile. You're not going to break your face if you smile. Okay? So, that being said, should you have snacks, if you want to bring them tomorrow, you're more than welcome to. All right, we'll give it another whirl. All right. Now, if that doesn't put a smile on your face, what? See, that's classic right there. Yeah. Don't smile. You may break your face. See, there we go. See, did your face break? No. Okay. No, your face didn't break. All right. All right. Fair enough. Fair enough. I know it is Monday. There's probably other places you'd rather be. Am I correct? Okay, now think about this. For some of you, you do claim there's other places you'd rather be, and I can't. I chose to be here, so I like it. I don't mind it. So, but in your case, you say you don't want to be here, and let's say that's just human nature. Okay, so with that being said, you don't want to be here, you want to be out working. Who's going to hire you with your current skill set? And maybe you already have that in mind. Your current skill set and educational level. Where's that? Okay. Okay. So would you rather be there now? Okay. But it's probably not your choice to be here. Or is it your choice to be here? Okay, all right, fair enough. I know, but it is one of those things too where, if now this is just my opinion, and I could be way off, but if I was an employer and you're looking at someone who maybe chose to, I'm not saying you can't graduate high school, but you just chose to say, I've had enough of that. I'm just going to branch out on my own. Now this is just my opinion. I'm not saying that it's anybody in here or anybody in this entire school for that matter, but the idea of graduating high school, for some people it may be more difficult than others, but it is one of the probably the easiest things that's going to have to be something that's accomplished by yourself. Whether it's some philanthropists, if you know what that is. We do have one of them in Sioux Falls. Does anyone think they know what a philanthropist is? What do they do with their money? how are they getting? It's not that they're getting. In a way, yes. Yeah, T. Danny Sanford is a philanthropist. In other words, he's donating money for different causes. Okay. So with that, you know, what we want you to do is be successful. But if you're maybe one of them philanthropists have said that graduating high school is going to be the easiest task that you may choose to do in your life. Okay. And no one should take that away from you, because it is an accomplishment, and it's a rite of passage from closing one door and moving on to the next. Okay? Yes? Why? Yeah. I meet the financial means that are needed to afford the things on a daily, I don't want to say, lifestyle. How's that? Okay? So, if that's the case, how many of you, now this is what we say, would want to be on the other side of that desk? How many of you would want to be on this side? And you're a teacher. Anybody? Okay? So with that, what do you suppose is a teacher's job? Well, yeah, that's just one part of it. Okay? Not to just educate you. Some people say entertain and engage the material and make it worth noting or worth saying, hopefully in the back of your mind saying, this is something that I think is relevant, that maybe I should know, because it's going to make me a better person. Whether you believe that or not, that's entirely up to yourself. But that's what and we need to evaluate you and all of this stuff, trying to keep everyone moving into the same direction with the same goals in mind. Yeah, and it's not an easy job. Okay? And especially if you think you're one of them that doesn't want to be here, and then with what goes on in here, you take away from the people who do want to be here. Does that make sense? Isn't that kind of selfish if you're one of them people that doesn't want to be here and try to make it miserable for everybody else then? And I'm not pointing any fingers at anybody, because I'm not looking at anybody. I'm looking at everybody when I'm saying that. But just think about that for perhaps just a moment. Okay? Now that you thought about it, we're going to move on. Okay. Now, not that I would be able to give an example on every aspect of every type of energy, whether it's electrical, mechanical, chemical, potential, kinetic, thermal, okay? All those different types of energies, okay, do follow this rule, okay? So with that, what that means is, so on a swing, okay, the energy is always changing. Now, one of the things to think about, we're talking about something moving through the air. So on a swing, you can only go so far because you're attached to that structure. Okay? So we're attached to that structure. So you can only go so far. So if it's something that is moving through the air that is not attached to something, what is it that's going to have an effect on that? Gravity. That's right. Okay? And we do perhaps a type of activity in the anatomy and physiology class. And it still amazed me last night watching San Diego at Pittsburgh. It was getting close to the end of the first half. Did anybody watch that game? Okay. And it still amazes me how these quarterbacks, but that's what they're paid to do. So who did Big Ben, well, I say Big Ben. So who did Ben hit in the end zone before the end of the first half? You remember? Well, I know it's not necessarily a wide receiver, but who? Okay? Someone said it. Did you say Hines Ward? Oh, Hines Ward played a while ago, didn't he? It was Antonio Brown. That's right. But my point is, you see Antonio Brown he's in the back of the end zone running towards the corner. How far away was that pass thrown? Probably 35 yards. So one of the things that these quarterbacks can do, they're kind of gauging, well, how fast is this guy moving and where's he going to be in just a little bit of time? Just like pheasant hunting. You don't aim your barrel of your gun right where the pheasant is as you're tracking it through the air, are you? Don't you lead them a little bit? But isn't that leading them though? The body of it. Yeah. Yes. Yes. But that's what I would do. I'm not a pheasant hunter, but I think that's what you do, pheasant hunters, right? You're nodding your head yes. Okay, maybe that was a bad example. Okay. Okay, enough? Okay, but my point is as he's running towards the back of the end zone, okay, so he doesn't throw right where he's at right now, does he? No, because he's moving in that direction, so he has to lead him. I don't know, it's something to gauge, just like that. And he hit him right in stride, okay? So my point is, even with all of that taking place, unless you can throw that ball probably 200 miles an hour, then maybe it would travel an arc like this. But when you throw it, you don't do one of those. You kind of put a little bit of loft on that. Because what's going to have an effect on that ball? Gravity. That's right. Okay? Conservation of energy. There's always going to be something that's acting upon it. When you break down chemical components, like today, macaroni and cheese, okay? There's certain substances in there your body breaks down, and when that happens, heat is given off, okay? Not only that, that's true with electrical energy, thermal energy. Of course, heat is going to be given off, all right? So all of these are what we're saying is that you can't create this energy or destroy it. Like I said, I can't really go through and explain an example in every type. All right. So what happens then is if you have no more energy coming into that system, okay, and you're not moving yourself, eventually that's going to begin to decay the amount of energy into it, and then you're just going to start to slow down. And when you're looking at that, you might be thinking, well, you're destroying energy. Well, no. What's happening is there's a little bit of friction upon where that swing set attaches to the frame, and with that friction starts to slow that object down. And then of course with any type of friction, what is going to be generated? Heat. Heat will be generated, and then that's just dissipated to the atmosphere then. Okay? So, for instance, when it comes to the block of, or your engine, you've got your pistons that are going up and down inside your valves. So yes, you have a lubricant or oil that tries to lower that amount of friction because heat's going to be given off. So how is that heat then dissipated, do you think? There's two ways. One, just guess. Okay, you have coolant flowing through. The water pump pumps the water through there. And then another aspect is, let's say your tomato soup. You get really, or chili, whichever. It's really hot. So what do you do before you start gobbling it down? Yeah, you blow air over the top, and when you do that, it helps dissipate that heat. So how is that happening or not in, but on the engine of your vehicle? What's circulating? The fan. So that fan is blowing air over the top of that engine. So what that does is it helps dissipate the heat. All right. One of the things that we wanted to do, does everyone have this information that wants it?